Okay, today's lesson is going to be on homeostasis and what it actually is and how it's maintained. Homeostasis is more or less, my own words here, a balanced equilibrium. Or another way you could say that is a balanced internal environment. That's a bit of an oversimplification, but that's kind of the gist of it. In order for you all to function appropriately, your organs work fine, your systems are in full operation, you have to have all their constituents, all their needs, their temperatures, their pH levels, you have to have them within a proper range. There is such thing as too much or too little of something. Your blood needs water. There is such thing as too much water in your blood. There is such thing as too little water in your blood. Your blood needs sugar. There is such thing as too much sugar, too little sugar. So homeostasis is generally a process that allows a constant internal environment to be maintained despite changes to the external environment. So if the external environment is really hot, your inside should not become that way. If the external environment is really cold, your internal environment should not fluctuate. It's all about keeping within range. I like to call it the Goldilocks principle. Too much or too little of anything is bad. You want to be just right. You want to be just in the proper range. If any of you wanted to get an A on a test, what's the range that you have to shoot for in order to earn an A letter grade? 90 to 100. If Lance got a 93, he has an A. If Alice got a 99, she has an A. It's within a range. A lot of the things that your body requires is not a specific value, a specific measurement. It's generally within a range. And we're going to go over about maybe 6, 7, or 8 of these factors that our bodies need to maintain so that we can function optimally. The one that I'm going to describe for you is going to be temperature. Now, the human body temperature needs to be about 37 degrees Celsius, which is about 98.7 degrees Fahrenheit. I remember being in high school. I remember being in middle school. I may try to psych myself out and thinking I don't feel well. I go to the clinic and my temperature measures out 98.5. Do I get to go home? No. Maybe your temperature reads out 99.0. Ooh, I have a fever. It's over 98.7. Do I get to go home? No, you're fine. Your body temperature isn't exactly 98.7. It can be within a range. This past summer when I got COVID, I wasn't feeling too hot. I had one day where I felt like trash. And we had these little digital thermometers. I took my temperature, and my fiance is a nurse, and so she deals with this all the time. I told her I'm getting to be about 99 and a half. She goes, you're fine. About 2 hours later, took my temperature again. I'm above 100. She goes, you're fine. Then I get to 102. I was like, do you believe me now? She goes, yeah, that's not good. So you have to be within a range in order for everything to function optimally. If your body temp is too hot or too cold, your organs will not function properly. Enzymes will not function properly. Some of you have taken AP Bio, have heard the term denatured. If enzymes are in an environment that is too hot, they will not function. That's called denatured. They'll lose their ability to perform catalysis. So can any of you think of other things besides temperature that our body must maintain within a proper balanced range for our bodies to, and our organ systems to perform to the best of their ability? What has to be balanced besides temperature? Anything you can think of? Water. That's a big one. Too much or too little water is not a good thing. In fact, I was going to say that for the end, but that's fine, Kate. In 2007, the Nintendo Wii was the most popular game console in America. You could not find it in stores. Some of you may have been trying to find a PS5. Well, you can't find it. That's what happens whenever there's the new state-of-the-art technology. Well, the Wii was the first one that had motion-censored remotes. You know, you've done bowling and play baseball, drive, all that stuff. And so it was in such high demand. And there's a radio station contest in San Diego, California called Hold Your Wii for a Wii, where whoever can drink the most water without peeing wins the game console. And so there's this 28-year-old mom who wanted to win it. I believe she wanted to win it for her son because you couldn't find it in stores. It was just totally sold out. And so she's drinking water, drinking water, drinking water, drinking water, drinking water, drinking water, drinking water. And she starts saying, you know, my head feels funny. And the DJs are like, oh, you know, that's fine. She died. She died. And she died from water toxification. You guys are walking, talking biochemistry experiments. You're a mixture of sugars and pH and water and gases and hormones and so much stuff. Your homeostatic responsibilities are to keep that within range. And too much water can kind of knock everything else out of balance. Some of you might be on a medication and you may have to take 1 pill a day. Imagine if you took 10. The amount of water this woman drank in like one sitting over a course of a couple hours probably was more than a human should drink in a day. I think she drank 2 gallons. That's one human should drink about 1 gallon a day. So she was in really bad shape. It just knocks everything else out of whack. If you took too much of a medication, it can knock out your hormone levels. It might knock out your neurotransmitter levels. It might knock out your sugar levels. Everything else gets compromised. So water is a big factor when it comes to homeostasis. You want to make sure it's all within range. Here's a question I bet you might be able to answer. If your water levels are really high, how in your body, you have a lot of water in your body, how would you expect your anti-diuretic hormones to respond? Would they become really high or would they really get low? Why would they be low? Well, what does anti-diuretic hormone do to you? Does it cause you to hold your water or lose your water? Hold it. So if your water levels are too high, what do you suppose the hormone is going to do? Okay, Sebastian wasn't here all last week and everyone else is just being quiet. So please interact. Talk to me. Emma, what does it mean to have diarrhea? Do you lose water or do you hold water? So if you have a hormone called anti-diuretic hormone, what is that going to do to you? Hold your water. Emma, your water levels are super high, unhealthily high. What do you think your body should do with all this water? Let it out. Will anti-diuretic hormone cause you to hold all that water or release all that water? So what levels would you want your anti-diuretic hormone to be if you want to lose water? Do you want those levels to be high or low? Yeah. If the hormone is low, you can release your water. And that's what her body wanted to do, but she was like, no, I'm going to hold it. And it didn't turn out very well. Okay, so we have body temp, we have water. I've got at least 5 or 6 more that you might be able to come up with. What are some other things, Nathaniel? What's that? Sleep is not going to be something that we're going to measure. I'm talking about like chemistry. Think of chemistry. What chemical components of our being, of our body, have to maintain within balance? pH levels. Our blood has a pH of about 7.1 to 7.4. That's very, very narrow range. If I measured Maddie's blood and it was 7.3, she's fine. If I measured Emma's blood and it was 7.1, she's fine. If your blood is too acidic, you get something called acidosis. Your blood is too acidic. That's not good. If it's too basic, that's called alkalosis. Your body is not intended to be too acidic or too basic. It's got to be just right within a proper range. What else in your body has to be maintained? Okay, we're going to call those blood gases. What gas do we need from the environment? Oxygen. What gas do we release into the environment? Carbon dioxide. Okay, I have at least two more. Think of diabetics. Sugar. We're going to call that blood glucose. That's actually the example I'm going to focus on today. One more. I mentioned this to you all last week. If one were to consume too much alcohol, one might suffer the effects of what we call a hangover the next day. Their head is throbbing. They feel like garbage. What is their body missing? Mackenzie? Electrolytes. We have to have a proper electrolyte balance. And I'm talking sodium ions, calcium ions, potassium ions, magnesium ions, and even chloride ions. Electrolytes help our brain and our nervous system conduct electrical impulses. And if you don't have this, then your nervous system isn't going to be able to function properly. Really bad headaches. So these are just a few of the factors that must be maintained within a proper range in order for us to perform optimally. Now for the internal environment, aka our insides, to remain constant, you must have it's two parts. For your internal environment to remain constant, you must have a blank. You must have one, a monitor. What this does is it detects the problem. And number two, a control. This will fix the problem or resolve it. We're going to do an everyday example, then we're going to do an anatomy and physiology example. I'm sure no one in here pays their own power bill, but do any of you have parents this time of year that want to open up the windows so you can get some outside air in the house? It's because power bills are not cheap, especially living in Florida during the summertime. Your power bill can probably exceed $200. Air conditioning is the biggest burner of energy, I guess you could say. Your refrigerator runs 24/7, but AC consumes so much power. The colder you set your AC, the more power it uses, the more money you need. So this time of year, power bills tend to be cheaper because we're running our air conditioners less. I know in my house at night, it's typical Florida. During the day, close the windows. At night, open them up. It's just Florida. Do I need a jacket or shorts today? Florida says yes for both. Well, in your house, in all your homes, your thermostat is set to a specific temp. In my house, the thermostat is set to 73 degrees. Thermostat is set to 73 degrees Fahrenheit. Nikita, what happens if the temperature inside the house, the air temperature, exceeds 73 degrees?
It's gonna go down.
How?
I guess I don't know how AC is.
Have you ever sat in your house and all of a sudden you hear your air conditioner turn on?
Yeah.
What caused it to turn on?
Temperature wasn't the temperature that you said.
Do you know what your house thermostat is set at?
Like 75.
Let's pretend it's 73 for the purposes of this. Let's say your house is like my house. You set it at 73. You're sitting there watching television, and all of a sudden you hear your air turn on. And any of you can answer this. In order for your air to turn on, what had to have happened for that to occur? It had to get hotter than 73. So when temps exceed 73 degrees Fahrenheit, the thermostat activates the air conditioning, the AC. I'm sure some of you have heard the AC running in your house and all of a sudden you hear it turn off. It was running and then it stopped. Now, barring the notion that it broke, let's say it worked appropriately, what caused the air conditioning to turn off? It will continue to run until what happens? It gets down to the set temperature. As soon as it gets down to 73, it's going to turn off. The AC will continue to run until the set temp is achieved. This is very much like your hormones in your glands in your body. Your hormones are designed to regulate various aspects of your body. Sugar level, calcium level, growth hormone, a multitude of things. We're going to get into all of them later in this week. The one that I want to focus on is going to be blood sugar. Blood sugar is also called blood glucose. How many of you know someone who is a diabetic? A lot of people. Hopefully this week I can teach you exactly what diabetes is. I'll teach you the difference between type 1 and type 2. The United States and Mexico lead the world in the percent of the population with type 2 diabetes. So it's, you know, it's on the rise. So it's important to know what it is. And hopefully for yourselves, you can avoid it. All right, well, a few things. Especially you former AP Bio kids, you better know this. Why do cells need sugar? Why do they need glucose? What do they use it for? Can you be more specific? Cellular respiration. Glucose is needed by cells for cell respiration. What do the cells produce when they have enough sugar and they have enough oxygen? Cells produce ATP. So you have to make sure that your cells get sugar. Well, the only way you do that is you eat it. You eat sugar. You guys have candy bars, apples, soda. That's a big one. Gatorade, a lot of sugar in that. Brownies, whatever. Almost all foods have some sort of sugar in it. Well, there is such thing as hyperglycemia. Hyper means high or too much. Glyc means sugar. And emia means blood. Hyperglycemia. Can you tell me what organ is actually able to detect if your blood sugar levels are too high? Your pancreas. What hormone does your pancreas release in order to lower your blood sugar levels because they are too high? That's right. The pancreas secretes insulin. And because your pancreas is considered an endocrine gland, where is it secreting this insulin? Into the bloodstream. Endocrine means secrete in the blood. Now, the first law in the conservation of matter says that energy, or not energy, matter cannot be created or destroyed. Matter cannot just disappear. The sugar that is actually circulating through your bloodstream cannot just go poof, gone. It has to go somewhere. Insulin takes the sugar to your cells. It lets the sugar into your cells. If it's in your cells, it's really no longer in your blood, and that's good. Too much sugar in your blood can be very dangerous for your actual blood vessels. It can really damage them and scar them. The sugar is in your cells. Your cells perform cell respiration. You make energy. Everything's fine. What is the opposite of hyperglycemia? Hypoglycemia. What does hypo mean? It means low. So let's say that you're fasting, you're doing a 24-hour fast, and you're getting really hangry, which, by the way, hangriness, hungry and angry, is an evolutionary behavior. You tell me, what is more likely to kill something? A full, satisfied lion or a starving lion? Yeah, because the starving lion wants food. And when you're hangry, you're more aggressive, you're more testy, you're probably more dangerous, because that's an evolutionary behavior. You're more likely to kill something to satisfy your hunger so you can keep on living. So next time somebody's getting on you for being hangry, it's not your fault. It's just, that's evolution. Anyway, the pancreas detects this. And here's a hormone that may be less familiar. I bet someone in here may know it. This hormone is the opposite of insulin. Insulin lowers your blood sugar. What hormone elevates it when it's too low? You want to know? Glucagon. Glucagon is the opposite of insulin. If insulin lowers your blood sugar, glucagon elevates it. But as I said, matter cannot be created or destroyed. Sugar cannot just appear. If Emma is doing a 24-hour fast, she can't sneak a brownie or a cookie. There's no food involved. So where's her body going to get the sugar from? I'll give you a hint. Where was it being stored? Oh, I didn't tell you this yet. You can just say, where did the insulin take the sugar? When I said if someone was hyperglycemic, where did the insulin take the sugar? Into the cells. So where does glucagon get the sugar from? Your cells. It basically takes it out. So glucagon allows cells to release sugar into the bloodstream. So it does the opposite. So I'm going to give you guys a little diagram here, and this is going to be homeostasis in normal range, and then what happens when you have too much sugar or you have little sugar. A lot of you just had lunch, so all of us, I had lunch too. I bet that right now we're probably a little bit hyperglycemic, and that's okay, so long as your pancreas works. If you have diabetes, then you would need to take like an insulin shot to get your levels down. So we're going to say that this range, let me lower it a little bit. We're going to say right in here is going to be good and happy homeostatic levels. If you're within this range, you're good. Let's first discuss what happens if you become hyperglycemic. You just went to a birthday party, you had a bunch of ice cream, a bunch of cake, and a lot of soda. Your blood sugar levels are really high. You're hyperglycemic. What gland detects this? The pancreas detects this. And what hormone does the pancreas secrete? Insulin. Insulin is going to allow sugar to enter two types of body parts. We've done this in the first semester. What type of cells or tissues require the most sugar because they need the most energy to function? Speak up. Don't be shy. I heard it, then you get all quiet. Muscles. The other one is the largest internal organ. It's right here. Liver. We store sugar in our liver and in our muscles. It's not disappearing, it's just being stored. Kind of like throwing your groceries in the trunk. This happens, blood sugar levels lower, or they decline. And you're back to normal range. So pancreas detects the actual high levels, insulin will be secreted and insulin will lower those levels. So let's throw in diabetes to all this. If you have diabetes, what will you not be doing in this little feedback loop? You're not going to be releasing the insulin. So is there anything that can actually cause the sugar to go into the cells? No. So where does the sugar go? It stays in the bloodstream, and that can be very dangerous. And I'll explain why. I'm going to kind of leave that as a teaser. Having too much sugar in your blood for too long is very dangerous. It can really do damage to your bloodstream, your blood vessels, actually. Well, let's go to the opposite of low blood sugar, or excuse me, high blood sugar. Let's go to low blood sugar. Let's say that you're eating, or actually you're not eating, you're fasting, and your blood sugar levels get really low. You have hypoglycemia. You're hypoglycemic. You're starting to get hangry. Not feeling completely right. What gland detects this low sugar level? The pancreas does. And what hormone does the pancreas secrete to try to resolve this low sugar level? It releases glucagon. Glucagon allows sugar to be released from what two body parts did we just say actually store the sugar the most? Liver and muscles. And when those are released, you're going to be back to proper blood sugar levels. Blood sugar levels increase. And you're back to normal range. This is a feedback loop. Okay, we're about going to stop there. I have one last thing I just want to teach you guys, and that'll be it for today. We're almost done. And if any of you want to pursue nursing school or med school or veterinary school, anything like that, if you mention this in your anatomy class or your comparative anatomy class, your professor will be very impressed. And that concept is called dynamic equilibrium. This is the last thing I want to teach you today. I say that because I remember saying this in college and my professor's like, whoa, very good. So, well, there were 200 people and no one knew it. So it's something good to know. This is really important. You are never perfectly balanced, ever. If you look at me, look at this. If you're watching the video, I know you can't see me, but my arms are outstretched and I'm not moving. I'm perfectly balanced. You are never going to be like this. Instead, you're just kind of teetering back and forth like this, but you're still within range. This is bad. Going like up and down dramatically. That's not good. This is dynamic equilibrium. Your body temp is too hot, too cold, and you adjust. So the whole thing with dynamic equilibrium is you are never perfect. The body never achieves perfect equilibrium, like a perfect number. You are never going to get a 100% on everything.
Good afternoon, Panthers. Please pardon the interruption for afternoon announcements. Congratulations to the Plant Chamber Orchestra who will be performing at the Florida Music Education Association State Conference this Thursday. We are so proud. Also, anyone interested in trying out the track this year, there will be a meeting next Tuesday, January 11th at the track at 3:35 p.m. Seniors, you're now dismissed.
There's a difference between being perfect and trying to achieve perfection. Your body is not capable of being perfect because there's so many factors. It's always back and forth, back and forth, back and forth. You can be really close. I mean, if I can give you like an example that we were noticing last year, the Bucks won the Super Bowl. Did they lose some games last year? Yeah, but they didn't. They still won the whole thing, but you can still have some flaws. Dynamic equilibrium is you're never perfect, but you are trying to achieve perfection.